In section 1.2 we talk a little bit about domain and range, and I guess I just want to hit on the fact that reminder that domain is deals with what x values we can and can't put in, and range deals with what y values we can and can't put in. So in this case, the domain is, of course, that x can't be 0 because we can't divide by 0. So our domain would be from negative infinity to 0 and from 0 to infinity. Over here in the second example, it's just a parabola. So domain actually is all real numbers. I mean, we're not going to have anything we can't put in there. So domain is everything, negative infinity to infinity. On the square root example, you'll notice by the graph that there's definitely a starting point here. And in fact, of course, imaginary numbers would never show up on the graph. So I know that negative 2 is a key here, and it's going to just continue on to infinity. So then the question is, well, can you plug in negative 2? And sure you can. You can take the square root of 0. So we put a bracket there saying you can touch negative 2. Finally, the sine function. Well, the trig functions sine and cosine have domains of all real numbers, negative infinity to infinity. Tangent does not, and neither do the reciprocal functions cotangent, cosecant, or secant. But sine and cosine have domains of all real numbers. Now for range, I'm going to do range in y. You'll notice here that there's definitely like a horizontal asymptote there. So again, we're talking from negative infinity to 0 and from 0 to infinity. I should put a little u there. Okay, we aren't going to touch 0. Now that doesn't mean we can never touch a horizontal asymptote or cross it, but we didn't in this case. If it did cross the asymptote, if for example the function came up and did something like this, then it would be all real numbers, but it didn't do that in this case. Coming over to this one, you'll notice there's a definite bottoming out period. This range is from negative 4 to infinity. Here too, there's a definite bottoming out, and then it continues up from there. So this one is from 0 to infinity. And my favorite, this trig function has a top and a bottom. The amplitude's 3, so we're going from negative 3 to 3. Real quick, talking about symmetry, an even function has y-axis symmetry, meaning if I plug in an x value, let's say 2, and I plug in its opposite, negative 2, I get the same y value. So if I plug in an x value and I plug in its opposite, I get the same thing. That makes it even. An odd function, if I plug in an x value, this by the way is x cubed, and I plug in its opposite, I get opposites. So if I plug in an x value and I plug in its opposite, the way to make them equal is to change the sign on one of them. Okay, so one more time, let me just explain that one, because and let me go back here. When I plug in an x value and its opposite, I get the same y values. So plug in x, plug in its opposite, they're equal. But here, if I plug in an x value and I plug in its opposite, I get opposites. So I plug in x, I plug in its opposite, and I get opposites. Actually, I could have put the negative on either one as long as I changed the sign on one of them.